Okay, so here we have my little microbrewery. All of these are different variants of cider. We've got, in total, we've got about 90 litres. We have 100 litres if that was full, but I had to give some to my mom to make apple juice with. But anyway, today we're going to be testing out my DIY hydrometer, which just allows me to measure the alcohol percentage of my brews remotely without having to open up the bucket, which is a big thing for me. It's more of a convenience thing. Anyway, so this is everything else here. You might hear some bubbling in that. I'll be actually kegging most of these in the next few days, so I'll try send an update for that if I ever get that going. But the star of the show today is this. So this was recently made up yesterday, I think it was, no, 2 days ago. It's been pasteurized, which means we killed off everything, and we're about to add the yeast. But before we do that, we just need to calibrate the what's it called, the density monitoring thing, which uses this ESP A266, and we're going to calibrate that using a normal hydrometer. So you can see it there. It's literally just kind of a glass bobbin. So we're going to calibrate it using that, upload it to my computer, connect to the internet, and then yeah, that's it. And we'll see if this hopefully is uploading. Right. So first off, okay, so you can see here, I'll try to take this out. There we go. So this is it. This is the device here. It is nothing spectacular. It's just a ultrasonic distance sensing module that you bought online for $1 or €2, and some perspex to kind of give it a bit of to create a fixed distance which we can use to measure. So what we're going to do now is drop this in. I'll do damn, alright, nice to go. Yeah, I was hoping to do a close-up shot of this, but I'll have to wait for the day. Very simply, the way this works is you drop this in the water and you just read at whatever point it is around here. So I suspect this is going to be, because I've added sugar or anything to it, it's probably going to be around kind of the 50-60 range. But a little closer look now. So here we go. I sterilized this beforehand, so don't worry. Yeah, so I don't know if you can. A better way to do this actually must be, so it's about 64, I would say. Actually, this is the better way to do it, but I can't actually know that well. I was hoping not to have to do this, but yes, there we go. That was always this bit. So point out a bit there. Okay, so doesn't taste too bad if I do say so myself. So it looks like a weird colour there, and that's because that's a mixture of black currants and red currants mixed with apples. So a lot of what I try to do here is reuse different stuff we grow here that we have excess of. So we have tons of red currants and black currants. So I'll see if you can get, I'm not sure if you can see this or not. So that is, also my hand's not the steadiest. So yeah, I would say about 62 seems about right. If you're wondering if that's not sanitary, don't worry, I sterilized the whole thing before I put it in. Right, so 62, just gotta remember that. Now you can lock her up. No, wait, before we do that. Getting ahead of myself. Next, we gotta add the yeast. So we're using MO2 yeast from Apple Jacks. Is it Mr. Mangrove Jacks? Sorry. Anyway, so the yeast. So this is doing the full packet here, which is designed for 23 litres. So we are pretty much exactly, well, very close to that. So put that in. The last thing we want to do is add some pectolase. So what pectolase does is that you can see how it's very hazy there. Pectolase will just help reduce that haze, but I realised I have forgotten the pectolase, or at least it's upstairs, so I'll do that off camera later on, but it's just kind of this powder. Anyway, so now that's added, you can give that a bit of a shake. There we go. Perfect, alright. Obviously you can't smell this, but it smells, as you imagine, very dry, very yeasty. But it'll be interesting. So anyway, the way this works is this has an external power supply just to help keep it running when I'm going off. This is just an old USB that we weren't using anymore, which I just snipped off the edges, the ends, and soldered it to the ESP. And then this is just an old power supply for something. Anyway, so the way this device works, I'll just make sure that that is. I had this going so much smoother in my head. Anyway, yeah, that's in. Now, why don't you turn it on? Oh, there we go. Turn it on. Perfect, alright. So you can see here, blue light is flashing, or is on, which means it's running. Yeah, don't want to move that too much, obviously these connections aren't very solid. Not the best at creating DuPont connections, I realised the other day. So here we have the program. This is just uploading to the ESP as we speak. There was a few issues with this. I was at this for a couple hours after that last clip, but it's working like 95%. I know there's a few other issues, but to be honest, the fumes from the buckets were starting to get to me, so we leave at this and we'll come back to it at a later point. But anyway, so the code should be uploaded about now. Here we go, connected to the Wi-Fi. And now it's asking to perform a calibration routine. So the first thing it wants is the reference distance, which I've already preloaded because I knew that beforehand. That's just the length of the rectangle, so we can skip that. Now it's asking us to measure the bulk modulus, which to do that we need the hydrometer reading we took beforehand, which I believe was 1.062. So now that we've entered this, it's asking us, it gives us the equivalent density, and it gives us the calibration findings. So there's a mistake here. If you can find that, I'll go into it a bit later on, but see if you can spot it here. But the K, which is the bulk modulus, is about on par for what standard liquids are. Okay, so now that we're happy with our calibration so far, we can begin measuring the density. So here we go. It takes about density measurement once every 10 minutes thereabouts. So here you can see the first density measurement has been taken. So it tells us the time of flight, which is just the time it takes to travel from one side of from sound to travel from one side of the rectangle to the other side. You see that's very quick, and it's traveling a distance of 0.27 meters. So this equates to a speed of about 3,800 meters per second, which is very fast. It's about twice the speed of sound for a liquid. So I'm not sure if this is just because the cider I use sound travels very fast in that, or if there's some other mistake. So it's about double, so there's a chance the time of flight or the reference distance is off by a factor of 2. So it's likely not the reference distance because I measured that with the ruler as well to second guess it. So the bulk modulus, like I said, there's something wrong with that. If you can figure out why that was, let me know. I think I've got an idea as to what it is, but I'll make a breakdown video as to what I think happened there. But basically, this was resulting in a density measurement of about 150 kilograms per meters cubed, which is a good bit off what we know it should be. It should be about 1,060, the density measurement we took beforehand. So even though that value isn't correct, it's still alright for the application I'm doing now. Hopefully we can fix that, but for the time being I'm just looking for changes in density as opposed to the actual density. I want to be able to track it over a time. So for the time being it's alright, but there's still some issues to sort out, which we'll address at a later point. On a positive note, though, the Google script is working which I'm using is working very well, and we're successfully uploading to the drive. So this is uploading to a Google Docs document, which I will show you now. Okay, so here you can see what's been uploaded to the Google Docs so far. The majority of these values, bar the last two, which were highlighted at the bottom there, are all kind of garbage values. They were just what was happening as the values that we're uploading as I was testing it out. So what's important, though, across all of these, even the garbage values, is that the time of flight, which is what we're basing everything off, is consistent. So that means that's a very good sign. So you can see here the density is kind of up and down the place, and that's because of those calibration issues I was mentioning before. But yeah, so far so good, quite promising that we've the time of flight consistent. We'd expect to see this increase as the density drops. So hopefully that will steadily go up, and then once we get the density issues sorted out, we can get some actual accurate density readings. Okay, so that's all for this video. Thank you very much for watching. If you have any feedback or comments, please let me know, and hopefully I'll see you again.